regenerative damper, and the presenter is John Georges. Welcome, John.
Hello, SAE. Thank you for having me. It's truly an honor and a privilege to be standing here as a finalist in this prestigious competition. Our company, Ganaio, draws its name from classical Greek, meaning to be born again or to regenerate. We take this concept quite literally in our mission, to breathe new life into otherwise wasted energy. Our focus goes beyond innovation. It's about advancing the adoption of electric vehicles, pushing boundaries, and contributing to a more sustainable future. My name is John Georges, and my partner and co-founder, Shashank Reddy-Goli, could not be with us since he is in India, currently celebrating his wedding. Shashank and I first crossed paths while in the automotive sector nearly 7 years ago, where we earned a reputation for enhancing quality and efficiency on factory floors. While Shashank has pursued further growth in automotive within manufacturing and project management, I have continued to further and diversify my career in mechanical design engineering across the automotive and aerospace industries. Our mission centers around addressing a critical challenge in the electric vehicle landscape. It's driving range. Simply put, electric vehicles currently fall short in range when compared to their gas-powered counterparts. This problem trickles down into overloading charging stations or forcing automotive companies to add more battery capacity to their vehicles, causing them to become more expensive and less energy efficient. So we developed a solution to harness energy from the deflection of the road. Given that the average suspension deflection is 25 millimeters up and down for every meter driven forward, we capture a substantial portion of the 17 kilowatt hours that would otherwise be dissipated as heat. By converting this captured energy into electrical power, we seamlessly transfer it to the vehicle's battery pack, significantly extending its driving range. To make this solution possible, I introduce to you our high-output energy harvesting damper, a direct replacement for the conventional dampers in a vehicle suspension. A Ganaio damper outputs up to 2,000 watts. This translates to a 12% driving range increase depending on the weight and the energy efficiency of the electric vehicle. At the heart of our damper lies a straightforward arrangement of magnets and coils, utilizing Faraday's law of induction. As the vehicle suspension deflects up and down, a ring magnet moves past an inductive coil. While this alone is not a novel concept, what sets our idea apart is the addition of a free-floating magnet inside the coil. The way the magnets are arranged results in a trailing effect, where the outer ring magnet holds the inner ring magnet in position and pulling it from behind. While keeping them in sync, it doesn't require a complicated assembly of parts. This patented setup achieves a higher total magnetic field strength, directly increasing the induced voltage. Securing a utility patent for our innovative discovery, the design not only delivers exceptional results, but also streamlines the manufacturing process. Our approach involves a minimal number of easily producible parts, ensuring efficiency and cost effectiveness, unlike our competitors. In the realm of regenerative dampers, only a few OEMs, such as BMW and Audi, have attempted such innovations publicly. However, their attempts fell short due to intricate designs involving complicated gears, clutches, and flywheels, which lead to challenging manufacturing, assembly, and also a subpar life cycle. Examining the landscape of top Tier 1 damper suppliers reveals a notable absence of initiatives towards regenerative dampers. Why is that? It's because suppliers primarily focus on meeting current OEM demands rather than proactively innovating for future technologies. Research firms and individuals are no different than the OEMs in this regard. The complexity of manufacturing makes them cost prohibitive, and their effectiveness in power generation remains insufficient. Before delving into the cost effectiveness of manufacturing our regenerative damper, it's crucial to understand how such a product is valued. Let's examine the benchmark for efficiency. The Lucid Air is the most efficient electric vehicle currently on the market. Using a 118 kilowatt-hour sized battery pack, it's able to achieve a total driving range of 516 miles. Integrating a Ganaio damper set into the Lucid Air recaptures 14 kilowatt hours, which increases the total driving range to 580 miles. That's the equivalent of using a 132 kilowatt hour sized battery pack without the additional weight. Considering the industry standard cost, which is $150 per kilowatt hour, the energy supplied by the Ganaio damper set is valued at $2,100. The second crucial factor in determining the value of our product is its damping capability, since it is a direct replacement for traditional dampers in a vehicle suspension. By combining the energy value with the damper value, the total product value that the automaker is currently paying is $2,850. We anticipate that the total cost of manufacturing a Ganaio damper set will be around $1,250. Incorporating a hypothetical 30% profit margin, the new cost for the automaker is projected to be only $1,625. This results in a substantial 43% savings for the automaker on the added range. So where does a product like this fit in the market? Well, our product's market positioning aligns with the projected growth of electric vehicles. According to the current trend, it is estimated that 210 million electric vehicles will be produced from the year 2024 to 2030. Considering the price for a Ganaio damper set, the total addressable market can be valued at $342 billion. We have successfully built a prototype showcased in our lab setup and electric bike suspension. The demonstrated viability of our design has yielded promising results from our testing. Our next prototyping phase involves developing a full-scale version tailored for road-ready implementation into a vehicle, along with third-party data collection for verification and the next steps. To facilitate and accelerate this process, we are actively pursuing strategic partnerships. Our goal is to initiate pilot programs with multiple automakers, leveraging the interest already shown by executives we have engaged with. The objective is to convert these pilot programs into purchase orders, propelling us into high-volume production by the year 2025. While challenging, entering the automotive damper industry is a task we are prepared to tackle. With our innovative technology, we see the potential to disrupt this market and establish a firm foothold. Thank you, SAE, again, for granting me the opportunity to present today.
Thank you for a presentation, actually, wonderful one. Did you approach any of these giant companies like Tesla or Ford with your product? It looks very interesting for them.
Yes, of course, and they all seem very interested. And the problem is that they are waiting for a road-ready version of it to start those pilot programs that I spoke of. So once we are ready to start pilot programs, which is dependent upon investment, we will then reapproach the connections that we have made with those particular companies.
If you approach them and they approve your relationship with them, they can invest heavily with you.
What we have been told by most of these companies is that we are too early in the process and that we need to show some sort of proof of concept with third-party data collection. And for us to even get to the point of proving it out with third-party data collection, we need to be able to build this in a road-ready version implementation into a vehicle.
Do you propose to use gas compression dampers, or are they spring compression dampers?
We can do both. So the three main types of dampers that are currently used in the market include electromagnetic, air suspension, as well as hydraulic. And our regenerative component of the damper can be applied to each one of those. In fact, the best case scenario, which is probably the most expensive for the automaker, would be the electromagnetic style damper. But the reason why it would be worked in the best way is because the magnets themselves can be used electromagnetically to not only use power, but to regenerate it as well. So in the same way, depending on the customer's needs, it can be adapted to air suspension, where the air is used for damping. However, the regenerative portion of the damper would add some damping forces, although not enough. And so with that being said, it is more complementing the damper in that sense. And the same would go for hydraulic dampers as well.
So have you tested this concept against real-life data that is captured from an OEM?
Yes, so the 25 millimeters of deflection that is observed for every meter driven forward is actually direct data that has been supplied to us by Bilstein, which is a damper supplier. And by using that information along with many research papers which indicate the amount of heat wasted in a conventional damper, we are able to align that with the amount of power that we are actually producing from our dampers. To put it simply, because we're able to capture 14 kilowatt hours of the 17, that tells you that we have about a 85% efficiency on that.
Sorry, a follow-up question, John, before I give this. So all the data that you have shown is based on the assumption that there's 4 dampers installed on a...
Yes, that's right. A Ganaio damper set would replace all of the dampers. Mm-hmm.
You mentioned that you needed investment to be able to develop a road-ready prototype. What level of investment over what period of time do you think it's going to take to get to that point?
Right now, we are looking, well, actually haven't announced this publicly yet, but we are looking to raise $500,000 over the next year. So we will have a road-ready version within that timeline.
Great. Thank you, John.
Thank you.